Good evening, everybody. Good evening, good morning, depending on wherever you're joining from. I welcome you to this session today. It is something that a lot of you were waiting for. This is something that a lot of you will resonate with. So it's about breaking the barriers and reaching that top target score that we want to get to. You might have dream scores of a Q50 or a 51, but you might be someone who's stuck maybe at a 48 or a 49 even, or you're somewhere on the lower side of scores right now. But that's okay. Wherever you are starting from, you can get to your target score if only you are diligent. Nothing happens without that, and you prepare the right way. Today, my goal is to give you that right way of preparing, to give you that confidence that if you put in the right effort, then you can break this barrier and you can get successful. Now, how this is going to happen? The theme is around process skills, strategic review. Right now, these are just terms. I will talk more about them and we will understand. Good evening, Mr. Useful Facts. That's an interesting name. Let's get right into this and start on a very positive note with some inspiration for you. So, look at the starting score here. So, it went from a Q40 to a Q50, the dream score. This side, it started at a Q45, then Q49, and then Q50. So, it took time. And here, this Karan went from Q49 to Q50. What am I trying to show here? I'm trying to show exactly what I just said. No matter where you're starting from a low score or a high score or somewhere in the middle, you can get to your target scores. You can go to these links and watch these videos and pump yourself up with all of the confidence that you're going to need. I believe half of the battle is won if you're confident about it. If you just don't panic when you see a question and you panic, you must have noticed that you don't perform the way you could have performed otherwise. So get that confidence in and let's go on. Now there's a link in the chat which is about these success stories. Go on and bookmark that link and look at that in your own time. Now, all of these methods that I'm talking about, that I'm going to talk about today, which I said are where you prepare the right way. This correct way of preparation has already proven itself. These are the Q49 plus scores reported on GMAT Club in 2021. And just look at the number of stories that EGMAT students have. So 133 of these quant successes were by EGMAT students. And the next best is close to a fourth. And then the numbers, as you see, go down further. So this number, this data talks for itself. Now, if you want to prepare for a Q51, there are some things you have to do in the right way. The main thing here is that you need to build core skills for each subsection in quant. So there are two main subsections. There is arithmetic and algebra geometry. You need to build core skills. What do I mean there? I am saying that the usual way of preparing, where you do concepts and then you do hundreds of questions on that concept to just say that, okay, if I practice hundreds of questions, I'll be good to go. That is the practice based approach. While I am here talking about the core skill focused approach, where you build the skills that are needed to solve any kind of question. Now, when you build those skills, then no matter what question comes to you, 20 of those or 30 of those, you will be able to tackle them. It's not in the quantity, in the number of questions, it's in the quality, it's in what you learn from them. So you need to build core skills in two main things. First of all, you have to have solid concepts. I cannot stress enough on this. What does it mean? Say you are at school. It's your first day of school. You just got enrolled. And now your teacher says, spell the word xylophone for me. You would be lost. What? How do I spell that? Why? You don't even know letters of the alphabet by then. Those are concepts. You have to know your ABCs, right? We can't imagine spelling words like xylophone. Now, after you build your concepts, which is the foundation, next thing is to learn the process to solve questions. A lot of times, what happens is I know the concepts, say I know what prime numbers are, I know the definition. But when a question comes, I go blank. Now, what is this? How do I solve this? Why that happens is because although we know concepts, we don't know how to apply those concepts. So both of these things are absolutely necessary, and then you can say that you have built your core skills. Okay, and do targeted practice to achieve targetability. So after you're done, you've built your core skills, and now you are at a later stage of your preparation, and you realize that there is this thing that I'm always messing up on, there is this concept or this kind of application or this skill. Then you practice keeping that very problem in target, work on that much. For that, of course, you need data that tells you what your problem is, and we will talk a lot about that as well. And every question that you do, I cannot stress enough on this point, every single question you do, make it a point to do a thorough strategic review where you dive deep to find out why you got it wrong. So every question has a couple of faltering points, typical places where people falter. And this exam is a super smart exam. It knows how to trap you. That's why those choices are there, which you get by solving your answers, by solving your way. Now, once you learn about all of those faltering points and you understand, okay, if I made this mistake, then this is the corrective action. If I made that mistake, then this is the corrective action. That level of a review needs to go into every question. Again, number of questions does not matter. I'm not saying do 1,000 questions and do strategic review. Even if you do this on a select few questions which give you the right concepts, the right application piece by piece in a progressive difficulty level, then you can do this and you will prepare yourself for the hardest of questions. Okay, I have some comments here. I'll just quickly check those first. Hello, Kshitij. Kshitij says I've already appeared once and got a Q47. So Kshitij, you wanna take the exam again, and what's your target this time? Seth gave the exam, got a Q48, want a Q50. Of course, we're going to help you break that barrier today. Can't break the barrier. You precisely are, your problem is the topic of the session. So you are in just the perfect place. We are all going to do this. And here's a story for you, Karthik. This is Vireshwar. He also improved from a Q48 to a Q50. So exact numbers, and you're going to relate more with this. So you are definitely going to get it, Chitij. Just put in the right amount of work and build that confidence first. Trust yourself, trust processes, and go for it. Now, the key to doing all of this, how is it going to happen? What is this right way? I mentioned this term at the beginning, process skills. I already explained strategic review now, but what are process skills? So, a very simple way to understand this is, say you have concepts here and you have GMAT level questions here on the other side, and there's water between. You can't walk and cross. There's a bridge between those two, between concepts and that GMAT level application. That bridge is process skills. These are what help you apply concepts, use your concepts into those GMAT style questions. So imagine this, your bridge is broken. How are you going to get to that GMAT level? How are you going to get to the other side? You can't, right? That's the importance here. So this, I think, gives you good perspective of what process skills are all about, why you need them, what they are, what these 7 names here are. I'm going to talk about all of that. Akshay says, is my target score too lofty if I want a Q51? Not at all, Akshay. In fact, aim for the sky. Aim for, what do they say? Aim for this, you'll at least land here. I am saying you aim for this, you will land right there. You just have to do the right work and trust yourself and be diligent. This is the most important thing. A lot of times we start something, but then after putting, say, 1 week or 2 week into it, we just get deflated, we don't have that kind of energy, we don't put in the work. Then it can't happen. You have to be serious about this. After all, think about the score that you're aiming for. It's the top percentile. You have to be at the top to get that. That means you have to put in the right amount of work, but you can get there. So these seven process skills are the skills that you apply, that the skills that you need to go from a question to the final answer. It's all of those things that you do in a solution from one step to the next. These are the skills that you see during the process of getting the answer. I'm not going to talk about all seven at once. That'll just be too much information. I will talk about them little by little as we keep using them in questions. That's the best way. Meanwhile, you have a link here about all of these process skills. Watch these videos after the session. You are going to have at least 2 to 3 questions, good examples for each of these process skills. When you see these skills applied, that's when you'll best understand. Of course, you're going to see them in the session, but then a lot more questions are here in this playlist. So make sure you check this out. These are the video lessons I'm talking about. Now, what will happen once you learn process skills? How will these seven names help you prepare the right way? Or how will these help you break the barrier? Let me tell you. Tell me one thing. You solved a question and you realized that the question said x is a positive integer, but when you got your final answer, you got two answers, x equal to -2 and +2. And what you did is you marked both of them. There was a choice which gave you both of them. You're wrong because the question told you it's a positive integer. There, when you later review it, it's highly likely that you just say, "Oh, I made a silly mistake. I didn't read the word positive." Everybody says that. Everybody, believe me. But when you just call a mistake silly, you are just not giving it importance. You are just brushing it aside. You'll be like, "Okay, it's just a silly mistake. I'm not going to make it every time." But you are. It's a trend. If somebody tends to miss constraints, then they repeatedly miss it. It's a constraint in the question given on what X can be. This way, every mistake you make will now have a name. You will have a cause for it. You will either be able to say that my mistake was because I didn't know the concept only, that's a different story, or you will find out that there is some process skill that you made a mistake on. There is some process skill that you need to fix. Now, suppose you review 15 questions and you find 10 out of those wrong questions have the same thing. I have missed constraint every time. Then you have an action plan. You know you need to be more cautious about that. Next time you see a question, you will specially be on the lookout for that. Oh my God, is there a constraint I'm missing? That's the power. That's finding out my weakness and fixing my weakness makes me stronger. That's the best way to become better, right? Don't repeat your mistakes. So that's the theme here. Attribute causes to your mistakes and keep getting better every day. Now, right now, all of this introduction, well and good, but time for some action. So, you are going to solve 9 questions with me here. Every time you solve a question, I get responses, then we discuss answers right away. Now, no answers in the chat, please, because that impacts somebody else. Maybe somebody's leaning towards a choice B and then you write A. That person will start doubting himself, even though you might be wrong. So let's not do that. You're going to get polls in the chat and you mark your answers in the polls. Ashish, can we have the first link, please? You are going to have the first question poll. Just open that. You fill in your answer, mark your answer, and come back here. Let's see. Okay, one more thing before you get there. These are two main skills that you are going to see in this question. Although, already warning you, don't just think I have to somehow translate, I have to somehow infer. No, do it your natural way. If you are somebody who solves questions methodically, then you will naturally be using these. Now, what are these? Time to talk about these two skills. Infer. What is the infer process skill? Well, infer means to take out meaning from something. Suppose I say that x is an integer which is divisible by 2. Okay, that's a long statement. X is an integer which is divisible by 2. What am I really saying? I'm just saying x is an even number, right? So what I said was if an integer is divisible by 2, then that means this number is even. So this that means that I did this inference, what I drew from what was given. This is the most heavily used process skill because every time you have any information, you take something else out of it. You keep finding out, okay, if this is what I have, then this is what I mean. If this is what I have, then this is the meaning, and so on till it becomes very simple, and there's nothing more to derive from it. Translate. Translate, as we use it usually, is when we change something from one language to another. Here also, it's just that you are translating English to math and math to English when needed. When you have a long question, say 3 sentences, 4 sentences, a lot of times you might just get overwhelmed by the length of those questions. Translate is going to help you with that. It's going to help you get rid of that fear of length. How? Read just a part of the question. Say you read the first 6 words and you have something there of in that relationship, there is something, you change it to its mathematical form. Suppose it says x is 2 more than y. Then why would you keep that sentence? X is 2 more than y. I would just write x is equal to 2 plus y. That's it. So you keep changing little chunks of those words from the question into math, and then you will see everything that you have to do with it. Without that, it's just a bunch of words. It's just sentences that you will get confused with. If you are somebody who reads the question from start to finish first and then starts solving, then break that habit right now. Read it bit by bit, process it bit by bit. Okay, so these are two main skills for now. We will keep building on these skills as we go. I hope everybody understood the idea here, and you'll understand better when you see the question. So the form is here. This is the question. No answers in the poll. All the best. Okay, time's up. Look at this. The accuracy data for this question is out, and it's a pretty low accuracy, 32%. So that means 68% of the class got this wrong. But it's okay, it's only the first question. Learn from every question and apply it further. So, look what happened here. Let's read it part by part. That's the theme. What do I have? A and B are two positive integers. So 1, 2, 3, 4, anything. They're just greater than 0, such that A squared divided by B gives an even number. Okay, so these two integers, I first square A, then I divide that by B, and the result is still an even number. What is the remainder when a to the power b plus b to the power a is divided by 2? Okay, that's pretty complicated. The final question. I have a weird expression. I have a to the power b plus b to the power a. And then I don't want the value or anything. I have to divide it by 2 and then give the remainder after that division. So, pretty involved. But it'll become very easy if you understand what this is asking. If you simplify this, if you try to write things in a different way or frame what is said in a different way using what you know. Look, remainder when any number is divided by 2. What can that remainder be? It can either be 0 or 1. Every even number, when you divide any even number by 2, the remainder is 0. When you divide any odd number by 2, the remainder is 1. So really, this remainder that I'm trying to find out, it's either 0 or 1, and it depends on just one thing. It depends on the even odd nature of the dividend, the thing that I'm dividing by 2. So here, if I just find out whether a plus b, a to the power b plus b to the power a is even, I will be able to answer the remainder. So if I find out that yes, it is even, then my remainder will be 0. If I find out that no, this is not even, then my remainder is 1. So already this has become one layer simpler. Instead of thinking about a complicated expression, dividing it by 2, then finding the remainder, now I just have to check whether this thing is even or odd. Even now, there's more. This, first of all, is a very important translation. We said something in a different way. We modified the language. We reframed the question in a different way. Now, there's a very, very important concept in even and odd numbers that if any number has a positive power on it, then its even odd nature does not change. For example, you think about the number 2. This is an even number. Now, if I put any positive power on it, 2 to the power 1 or 2 to the power 2 or 2 to the power 20, all of these numbers will be even. A product that has even one even number is even. This in fact has everything even. Similarly, if it's an odd number that you start with 3, then whether you do 3 to the power 1 or 3 to the power 2 or 3 to the power 5, the result will still be odd because it's a product of all odd numbers. So here, if positive powers do not have any impact anyway, and I know a and b are positive only, then this power on a to the power b, this power is irrelevant. Similarly, this a, which is the power on b, will have no impact on the even odd nature. So essentially, whether I find out even odd nature of this or I just find out even odd nature of a plus b, it's the same thing. Look at how simple this has become. Now the question is only and only asking what is the even odd nature of a plus b. Okay, so I've understood the question. Now, what is given to me? I still haven't used this piece of information, right? First of all, you people tell me if a squared is divided by b, two integers, division resulting in an even number. Can you tell me anything about a and b, about their even odd nature? Let me see. I know there are a lot of assumptions that you people are making, because of which the most popular choice, the most popular incorrect choice is A. We'll talk about that. So tell me first. There's going to be a 2-3 second lag. So we're going to wait for this. What can you tell me about A and B? Okay, I can wait here for 10. No? What does no mean, Sanmati? Do you mean you cannot say anything? What's this no? I said, what can you say about A and B? Did I ask something else? Okay, nothing. Vandini says both can be either even, one odd. Okay, in the second case, Vandini, one even, one odd. Can you give me an example? Either B is one or both are even. Okay, you are close to something, but you're not there yet. A is even, B could be even or one. You are also close, but you're not there. A can be only even. Aditya Narayan, that's correct. A can be only even, but what about B? Both are even. Nope. Aditya, you have gotten it. Kshitij, yes. A should be even. Shivangi gave an example to everybody who said B has to be 1. Please read her example. B does not have to be 1. That's good. So, all of you combined, you have information. Now, let me tell you how to really do this. It should not just be in the head, and you should not just depend on finding the right numbers at the right time. When you're under time pressure on the exam, these numbers don't just normally come to you. You still feel insufficient. Here is the correct way, the methodical way of doing this. So, a squared over b is even. Just multiply b on the right side. So a squared is even times b. Now it's because of this even here that this product a squared is going to be even. This is an inference I made. Now, a squared is even means what about a? We just found out that positive power does not change even odd nature. So a is even. So everybody who said a is even, good. But some of you assumed that b can only be 1 if it's in the denominator, and that's where one example and couple of examples now have come to prove that that is not the case. B actually can be anything. One example that we have right now here is a equal to 6 and b equal to 3 by Aditya Narayan. That's correct. Just try that out. 36 divided by 3, that is going to be 12, which is an even number. So do not make assumptions. What you people did here, think, why would you say that 0 is the answer? You thought a plus b is even. That means you thought that a is even anyway. You thought that b also has to be even. But because we can't say anything about b, we really can't say anything about a plus b. And so the correct answer here is choice C. Okay, so here this was a relatively simple application, but something that also prepares you for another kind of faltering point, which is assumption. When you just assume something happens without really thinking about it, without really putting pen to paper, don't do this in your head, write things down. So you see here what all happened. Translation helped you, first of all, rewrite your question, reframe your question in a much simpler way. Inference helped you find out that A is even and B could be anything. We could not say anything there. Okay, good. So everyone, 50% of you went here. I hope everybody is absolutely clear about this. Are we clear about this, everyone? Good discussion we had here. You can just write C for clear in the chat and I'll get it. Meanwhile, it's time for me to introduce yet another skill to you. It's the simplify process skill. Simplify, as the name suggests, is meant to simplify things. It's meant to make them simple. Sometimes expressions or equations, they look super complicated and you just get scared by looking at it. Oh my god, how can I solve this? This is not doable. In those cases, take that little step and try to simplify what you have. A lot of times you would not believe how much simplification is possible on something that looks so difficult. So keep simplifying as you go. Keep getting things in a better format, something that's more understandable, and you'll see how close you keep getting to the solution. Okay, everybody says C for clear. Good. Then we are ready for our second question. I'm going to show it on the screen after the poll comes up here. In fact, I don't want to show it on the screen because then you'll again put comments in the chat. Or if you promise, if you do that again here, then I'm not going to show it, but one more time. Link is here. All the best. Love the chat. So Ketty struggled and everybody just, it's okay, try, do this, you can do this. This is so good. You people are already a group. This is very nice. Help each other, help yourself. So Ketty, I'm gonna ask again after this solution is done. I'm gonna ask something. Right now, just trust and look at the solution step by step. So I said sometimes expressions look crazy. This is what I meant. But that simplification can help you there. It can change something that looks as difficult as this into something which is very easy to process. Let's try that. Now, one thing here is if you don't know the concept, what factorial even is, then you will not be able to start. So, you first need that definition. So, n right now I know is just something greater than 4 and it's an integer that I found later. I want the value. And this statement had a lot of exclamation marks for people who don't know. It's a factorial. Now, what is a factorial? This is it. So, n factorial is the product of all integers starting from n going all the way to 1. So, for example, 5 factorial. That's going to be 5, 4, 3, 2, 1. Multiply all of that. 10 factorial will be all the way from 10 to 1. Okay, that's the definition. Now, okay, so Ketty, you knew factorial. Everybody else who did not, let's hang in there. And this was a hard question, A Krishna. Okay, so how do I simplify this? Do I see something? Well, I already see one thing. I see n factorial in both of the numerators. I know I will be able to cancel that out. So at least one part of this mess I will be able to clear. Second, in the denominator right now, everything looks so different. But I know how to use the definition of factorial. Think about it. Can I rewrite 5 factorial as 5 times 4 factorial? 4 factorial will take care of everything from 4 to 1. Similarly, 10 factorial is equal to 10 times 9 factorial. That way, which one is the bigger number here? It's n minus 3. If I write n minus 3 factorial as n minus 3 times n minus 4 factorial, the rest of it, then yet again I will have something common in the two denominators. And now cancelling out already makes it very pretty. So this simplification got us till here. Just look at what we started with and look at what we have. We only and only have n in one place without factorials. Now, when you try to solve this further, you see even now this 4 factorial can be rewritten as 4 times 3 factorial. You can now cancel that again. And yet another simplification got you to this after cross multiplication. Who could have thought that this thing here on top is the same as n minus 3 equal to 4? And solving this gives you n equal to 7. So this is sufficient. Did everyone get this? Everybody who was confused, Ketty, you answer. Do you see how something very complicated can be turned into something very simple by using this process skill? By just taking one step. You don't have to know where you want to get to. You don't have to know exactly what the destination is. Take the next step. Okay, let's see. This is actually a good feeling. I'm so glad you're having fun. Shivangi says NC3 is equal to NC4. Why, Shivangi? Did you mean in general? 7C3 is equal to 7C4, but in this case, n is 7, so maybe you made some observation. And no, and I did not get this, Getty. Now, same story for statement 2, but first, let me just reject choices that I can. If statement 1 is sufficient, I can already reject B, C, and E. Ashish, can we check how many people went for B, C, and E? That will make it very clear that these people made a mistake on statement 1 already. Now, statement 2. This looks even harder. So for all those of you who got confused by looking at the first statement, this must have been a nightmare. But the processing is not different. You still need to try to get the same denominator throughout. You see there's n minus 3 factorial here, n minus 3 factorial here also. There's one n minus 4 factorial. So what you can do is you can again rewrite your n minus 3 factorials the same way as you did there. All of these then will have n minus 4 factorial common. Then cancel out everything which is the same in the numerators and the denominators, and this simplification will get you here. Okay, it's still not super pretty, but it's better than where we came from. Now, there's scope for more. Look, so I have this term as a constant. This does not have any n, and the other two have n's. So, what can I do? I can still cancel out 3 factorial, by the way. Now, this looks neater because there's no factorial whatsoever. Now just rearrange it so your n's are together and your number is separate. And then you're going to see that when you get these two together and you actually do the subtraction, you get n minus 3 over 4 times n minus 3. Again, n minus 3 gets cancelled out and you get 1 by 4 equal to 1 by 4. What's this? 1 by 4 equal to 1 by 4. That's like the newest information I got today. Well, this is obvious. If this is obvious, if this is something which is always true, what that means is any n in the world that you put is going to work here. Any n, because n really had no role to play. It was just as if somebody rewrote 1 by 4 equal to 1 by 4 in this messy format, because it's the same throughout. We kept writing the same thing, right, in a different way. So n has no role to play means n could be anything. So you cannot get the exact value, which makes this not sufficient, and your answer becomes A. Now, here, what do I have? Two answers, 7% each for B and C. Okay. Now, those of you who thought that, what's the next most popular choice, Ashish? And what did we have for D? So, Gabby, right now I am explaining things to you. I'm taking my time explaining things to you. And right now, you should not even be worried about time. It's like when I know what to do, I don't have to spend time thinking what to do during the exam. Right now, it's the time to build the skill to be able to solve this. This is totally doable. When you know what factorials are, when you know how to simplify factorials, you can do this in under 2 minutes, not even 2.5. You just need to build the muscle for this. It's going to take time. Don't worry right now though. Right now, your focus should be on something else. I'm trying to show you the power of how one skill, simplify, can take you from something which is so messy into something which is so, so simple. It's just about taking one step towards that simplified expression. Okay. All right. So, questions that I could not take here, Ashish will try to respond to you. How does n minus 3 factorial become this? Everybody says this. Justin, tell me one thing. What if I say 5 factorial is equal to 5 times 4 factorial? Does that make sense to you? Everybody who asked that question, who all understand when I gave this example? 5 factorial is equal to 5 times 4 factorial. Okay, it's written here now. You read this. The Ashish responded to this in quite a lot of detail. Read this, and you're going to see how every number you keep that, and the next smaller number is the factorial that you continue. This would take so long to solve even after simplifying. It will not. That's what I'm saying. It takes time right now because you don't have the skill. You don't know how to tackle this stuff. You don't know how to quickly keep simplifying. When I don't know how to do something, I am going to find it hard, right? I'm going to feel, oh my God, this is very hard. I'm going to take very long. But once I'm prepared for it, once I learn, once I train for it, it's not going to be hard anymore. You gotta trust yourself. You really have to. Now, all of us are going to go into question number 3. Let's have the poll here. And then I'm also going to show it here on screen. Okay, here we go. All the best. Okay, accuracy is here, 65%. The comment section was pretty interesting. We had such variety, right from I found this easy to this is messing with my brain cells something, and then there was somebody who said this is monstrous, and somebody else said this was fun. That variety we saw here, it's just about how comfortable you are with a certain skill. Now, the best part will be when all of us feel comfortable by the end of it. It's a lot easier than it looks. Yes. Thank you for saying that. And now I'm going to prove that. So it looks crazy. No, no doubt about it. Everybody finds this weird. Now, you are given that for every positive integer, 1, 2, 3, 4, there's this definition. There's AK, which depends on K. So A1 would mean 1 plus 1 over 2. A2 similarly. I am asked something about the product of all of these from A1 to AN, and I don't even know N. I want to know whether this entire product is an integer. This looks so weird to even ask. There is no number. How do you expecting me to find product of numbers that look like this? They don't look nice. But then it's all about just taking one step, doing one thing that you can do. So it's defined for all positive integers k. Why not write some terms down? Just how I said a1 is going to be so and so, let's write some terms down before we get scared. Now, k equal to 1, this is what I talked about. 1 plus 1 over 2, this is going to be 3 by 2. Let's find the second term, a2. This is 4 by 3. Nothing looks nice till now. It's not like 3 by 2 became 1 and then, it keeps doubling. Right now, I don't see a pattern, and it's too soon to even look for a pattern. It's only the second term you've written, third term, fourth term, and so on, so on, so on. Okay, I don't know how this is going to help me, but I wrote some terms. Now, I have to remember what my question is. The question is product of all of these. Let me write that. Why just stop at writing individual terms? Let's express the product. The moment you do that, magic happens. You will see almost all of these numbers get cancelled out. As Aditya Narayan says, almost everything gets cancelled out. Siddharth also says it's easy, just get a few terms. So it's about let me do this one thing. Let me just see what these terms are. Let me write one step and see if this can be simplified. And this becomes this n plus 2 over 2. Something that was unimaginable is actually just this little expression. This is the product. Now if you're saying is this product an integer, don't forget the question. So is this division by 2, is this going to result in an integer? You're just saying is n plus 2 over 2 an integer? That is n plus 2 even? If it's not even, then this is not going to be an integer. So this simplification that happened here, this complicated product I had no idea about, now is just this little expression, and I can clearly comment on what I have to do. So from this question, is this product an integer, you have come to is n plus 2 even? Your question only has become so simple. Now, if you do all of this analysis, this is called the question stem analysis. You've just read the stem here. If you don't do this, then statements are also going to confuse you. Now that you've done this, just see how easy statements get. So, statement 1, n plus 1 is a multiple of 3. Okay, so n plus 1 is 3p. I can write it that way. Or n is equal to 3p minus 1. Why am I doing this? Because my question is about n plus 2. So I first need to find something about n. So here I found out n in terms of something something. Now, when I write down some values, I had no idea what p was, right? It's just some multiple of 3. So as you vary p, so you put p equal to 1, p equal to 2, you get two different values of n. These only tell you that n can be even also, n can be odd also, which will be the same for n plus 2. If n is even, then n plus 2 is even. If n is odd, then n plus 2 is odd. That makes this statement insufficient, and so you eliminate choices A and D. So it became very simple once I knew what I was looking at. I was only looking for even odd nature. So this n plus 1 multiple of 3, nothing scared me. Otherwise, this would have been, oh my god, I anyway did not know what n was. Even now, you're not giving me values. You're just saying n plus 1 is a multiple of 3. How many multiples do I take? There's 3, 6, 9. There are infinite multiples. How far do I go? How do I do this? All of those things, get them out of your system. Make simplifications that give you a simple question to work on and look for just that in your statements. Siddharth says from the simplified form, we can say as well, n needs to be even. Siddharth, that's actually good. I was thinking, why did I not write one more step here to say, is n even? That is the simplest level to which you can take this. Good, you're thinking properly. Statement 2, n is a multiple of 2. What is this? What does it mean to be a multiple of 2? This anyway means it's even and you're done. That is what you were looking for. So statement 2 is sufficient. Correct answer is B. So although accuracy here was good, 65%, still 35% of us who were struggling. Are you guys clear with this now? Again, you can write C for clear in the chat if you're clear. What else do we have here? Meanwhile, I'll read the chat. Try to find the nth term. Okay, we have our C. Anuj says, my analysis of the question stem. Numerator should be a multiple of 2. I did not simplify it to what numerator, Anuj? Numerator of what? The final simplified expression? I have a couple of CC, by the way, so everybody's clear. That is good. Anuj, so I will show the next question to everybody. Meanwhile, Ashish will take your question. And let's look at the poll for question 4. Here we go. And now you also have it on my screen. All the best. Oh, this one has some very good accuracy. 81% with choice A. Good. So everybody already is in the groove. Huh? I'm not going to be scared of crazy expressions. I'm going to trust myself. So here, let's go over the solution. Once you find the concept tested, it becomes quite simple. Yes. So one thing is knowing the concept. Another is to apply it properly, to stay methodical, to follow the process, to not make assumptions. SP says I substituted a couple of values. Substitution and putting values is not something I would ever recommend unless you have a very strong basis for the values that you're taking. That this is my logic and that's why I'm taking these values. If it's random values, it's not going to work. So look at the solution here, SP, and let's see how it's going to work. So what next says we need to know if y is even. See, you simplified the question. Good. That's what we have to do. Look, x and y are positive integers, so greater than equal to 1. You already know x is odd. Question is about xy. So how is the product of two numbers going to be even? Well, if x is already odd, all of the load of making this thing even is on y, because if y was odd, then odd multiplied by odd result would have been odd. So really it comes down to finding whether y is even. So good, so this simplification is good. Now statement 1, I have my goal set. What is it that I'm trying to find out? The even odd nature of y, just y. So look how from statement 1 I can get that. So when I look at statement 1, this right hand side, I can easily find the even odd nature because of this 6. This entire first term is even, second term is odd, so their sum is odd. Now x cube y, this is equal to this thing, so that's also odd. Now if the product of two numbers is odd, what does that mean? It means both of them are odd. And if both of them are odd, I anyway knew about x, by the way, but this also means that y is odd. So here you get a sure no to the question you were asking. You were asking, is it even? You get a sure no, and therefore this is sufficient. We eliminate B, C, and E. Pratik says, I focused on the right hand side of the two equations, already knew the nature of x. That's exactly what we did here. So, focusing on the right hand side, getting that this was odd, then using what you also knew about x. Even in statement 2 now, this is x squared plus y. I can get y out of it by taking x squared to the other side. This is what I have. Now I'll work on this slowly to see what I can say. I really can't say anything about 3k. I don't know anything about k, but 7 is odd, x is odd, so x squared is odd. So these two together at least are even, odd plus odd. But what about k? You have no information. So k can be even also, k can be odd also, because of which the final even odd nature of y is also going to change. The odd power of odd number will be odd. That will help in the first statement, says Siddharth. Yes, Siddharth. So x to the power 3 is odd comes down to x being odd, or x being odd given. It means x is odd that is given, so x cube is odd. Yes, that's what we used. Kshitij says one property which is helpful is if one number is even, the product must be even. Absolutely. For the product to be odd, everything needs to be odd. So well done here, guys. Look at the key skills. We simplified the question from product of x, y into just something about y. Then we made appropriate inferences in the statements. There were things given to us from which we said, okay, if this has a 6, it means it's even. 23 is odd. So their sum has to be odd. So this has to be odd. This so that I'm making inferences as I'm going. Same thing happened for statement 2. Okay. Now we are almost at a very comfortable stage with process skills, and I feel now is time to give you one more skill. You guys are now using simplify nicely, you are inferring nicely, you translated. We will have more questions on translate, but I can already see the strength in these skills. Now for one more skill, consider all cases. Let's keep this a little interactive. You guys tell me something. If I say that the product of x and y, xy, is even, what all can you say about the even odd nature of x and y individually? Let's see. Odd to any power. Nope. What about it? Negative. Okay, I'm waiting for responses. If XY, the product, is even, what can you say about the even odd nature of X and Y? And you have to write all possibilities that you can think of, even if it's one possibility, write it all in one comment. I mean, don't just keep it continuous. Pratik says one of them or both are even. Gabby says one is even. There, you missed a case. If you say one is even, which case did you miss? That both are even. Sabhyata missed a case. Sabhyata said both are even. But what if only one of them is even? Right? Amulya got it right. Akshay got it right. Amol, yes. Unwind, that's one possibility. Just one possibility, not all cases. One is odd. What? Both even or either even. Both even or one even. Kabiraj got it. Okay. Both are even. Missed that. Yes, Gabby, you missed that. This is what happens when you're trying to evaluate something and you miss out on a case, you fall into a trap that the exam set for you. It typically knows which ones you're going to miss, and that's why there are choices to always have the answer that you have. Yes. So this is precisely what consider all cases is. Consider all cases. When you're doing anything, don't miss out on things. And you're going to see the power of that when we come to questions, of course. So it's time for your next question, number 5. Let's have the poll here and then I'm going to open it on the screen. So everybody, since I just talked about it, don't miss it in this question. Here's your poll. All the best. All right, accuracy data is here. 35%, so it's pretty low. Unwind said this question is a very good question. I often make silly mistakes and forget to consider all cases needed to improve to reach to 51 from 49. Okay. Good that you realize that all cases is what you miss, but from now on, never use silly mistakes as the reason behind your mistakes. That was the main thing I talked about today. That no mistake is just a silly mistake, because that's just how we miss giving it its due share of importance. Give it the right tag and work on it. Now that you know consider all cases is the problem, fix it. Fix other skills also. Wherever you have issues, you're going to get to that 51, we promise. Now, Anuj says, had option 1 not stated that A is a positive. I think you're talking about some other question, Anuj. Okay, cannot be determined. X can be 0. Good. Vernax, you did not miss this. Most popular incorrect choice is B. So 35% is the accuracy, which means those people went with the correct answer. I'm not going to tell you yet. But so many of you, 65% of you went with B. What is so interesting about B? Look, think, how would this remainder be equal to 1? Remainder on dividing x by 2, it means you people thought x is odd, right? That's the only way. How did you think? So this number minus odd is equal to even. So x to the power 3y, you got odd, and then you were like, because positive power has no impact, so x to the power 3y odd means x is odd, and that's it. You got trapped there. We have not given that this is a positive power. Second, it's also possible that you did not have your concept correctly. You just thought no power matters. Whatever power you put, it does not impact even odd nature, but that's not true. Positive powers do not impact even odd nature. Let's look at the solution now. So, any integer is possible: negative, zero, positive. Is x even? I think everybody figured that out, because otherwise you would not mark B as the answer. Now, when you do this translation, you've changed the question into whether it's even or odd, then you just have this one expression to work on to find out about x. Now, first step that all of you probably did till here, that x to the power 3y is odd, that's good. But from here, assuming that x is odd because power has no impact, that's wrong. Positive power has no impact. So it's really a conceptual problem. You either did not know the concept, or you rushed here, or you just assumed. Don't do any of those. There are two cases possible. Case one, if y really is positive. If y is positive, then yes, it has no impact on the even odd nature, and therefore x has to be odd. But if y is 0, then what do you have? X to the power 0, which is 1, which is odd. So if y is 0, even then x to the power 3y is odd. So you can already see that x can be even or odd. Now, if you're wondering why I'm not taking negative y's, well, then x to the power something negative, it will not even be an integer. But we are already given that this is odd, so it has to be an integer. Even, odd, these are only integers. Okay, Siddharth says, I read questions twice. Are xy positive or any integer? So, Siddharth, what that really means is, in the language of the skills, one of these I still haven't talked about, it's that you're always careful about the constraints. This is good. This is one of the most important process skills here. So, here then, overall, all cases once you consider, you can tell that the correct answer is C. Now, look how something which wasn't actually hard became hard because we just missed one skill. We did this translation well, but all cases we faltered here. So then, when you are doing such strategic reviews, you got to write those things down. You need to write that, okay, this is the mistake I made. I have to do this kind of a fix. Next time I do it, I'm not going to assume. All right. Rog says I went too fast. Yeah, rush is another killer. Kshitij, watch the recording. Otherwise, post your question here, and I'm sure Ashish will be able to help you really well. Right now, we will all go into question number 6. I still have more for you people. I want you people to apply and feel confident by the end. But before I go there, tell me, are we having fun? Are we enjoying all of this? These questions, you think you're learning? You think you got something valuable here? Meanwhile, I'll see if there are any questions. Only thing to be careful in even odd questions. When even is raised to unknown variable, consider the power 0. Yes, that's when you get odd. So these are nice questions, yeah. Mhm. Questions are nice, but what about the learnings that you're getting? Do you see the value that process skills bring in? Do you see how they're going to help you characterize your mistakes from now on? Definitely enjoyable and informative. Thank you, Gabby. Let's have a V51 session as well. Juhi will be able to respond to that, Akshay. Okay, Kshitij got it. And we've put the link for process skills again. These are what you need to get to that final level, to get to that dream score you have, to break those barriers. Okay, good. Good that everybody is having fun. We are then going to go into question number 6. Let's have the poll. Okay, the poll is here. Vandini says this is a really nice session, emphasizing the techniques. Would really look forward if there's something for verbal as well. Vandini, definitely. Jui is going to respond to that. We are always going to be here to help you guys build those core skills. This is your question, meanwhile. All the best. All right, accuracy data is here. Correct answer is choice D, and 68% of you got that correct. Good job. This is a medium level question. Somebody was asking about that. Let's discuss this properly. A and B are positive integers, so greater than equal to 1. Is this product a times b to the power 4? Is this a multiple of 2? Again, you know what multiples of 2 are. Let's just not write it in this way. It's easier to just say, is a times b to the power 4 even? Then you also know positive powers have no impact on even odd nature. So it's just, is A, B even? Then we talked about all of the possibilities in which the product of two numbers is even. Remember? That really just means, is at least one of A and B even? If you get yes, at least one of them is even, then the answer is yes. If you get both of them are odd, then it's a no. So we're going to just see the even odd nature of both numbers. Or if we find just about one of them and we know that's even, then at least one part is already taken care of. So this is definitely simpler than what we started with. A times b to the power 4 being a multiple of 2. Nope. Is at least one of A or B even? Now, your first statement tells you that 2a plus b cube of that is even. Again, positive power on the whole thing does not have any impact. 2a plus b is even. 2 is anyway an even number, so 2a is going to be even. From here, you can infer that b is even. If B is even, at least one even or not, it's a yes. B is even. I don't really care about what A is. So this inference alone helps me find out that the product is also even. And so this statement is sufficient alone. We reject choices B, C, and E. Next up, statement 2. A plus 3B is odd. What can I say? In this first statement, I had 2A. This was easy. It's even, but here it's 3 times something. Never just make this rush of saying when I multiply by 2 is even, so when I multiply by 3 it's odd. No, it's going to depend on B. So here really there are two cases. It's the sum of two numbers which is odd. So there are two ways in which that can happen. One even, one odd. That's one way. But which one even, which one odd, that will give you two cases. So A odd and 3B even, or A even, 3B odd. If 3B is even, then B is even. And if 3B is odd, then B is odd. Both these cases were very important to consider. You don't know what the importance of this will be right now, but it always will be important. So never think, is it even needed that I consider all cases? Or is it okay if I just leave it till this? Maybe I'll be able to solve it. No, you have to write down cases, especially when you're checking sufficiency. Unless you get opposite answers, how do you know you've considered in all the cases? Suppose there are four cases possible, you've taken two. One gave you yes, one gave you no. Then yeah, you're done, you don't need to write the other two. But what if both of the first two cases gave you yes? You still don't know about the third or the fourth one, right? You have to continue, you have to write. So from here, I see at least one of them is even, so the product AB is definitely even in both of them, right? So this is also sufficient, and the correct answer is choice D. Okay, what? One should be even, another odd, Kshitij, yes. Zero positive even number? Nope. Zero is neither neither positive nor negative, but yes, it is even. 0 is even and non-negative, but non-positive. Victor, so 0 is non-negative and non-positive. It's both of those things. Okay, we're deviating here. Now, time for one more skill. Constraints I've already talked about. There was somebody here in the chat who also talked about, where he said, I'm always careful about these things. Is it given positive integer or is it any integer? That's what constraint is. Constraint is every time you have an unknown in your question, you have a variable, and they put some constraint on it. They put like, you can't just take any value in the world for this. This is what it's going to be. It's that kind of a limitation. So if I just say x is increased by 2, find the value of x plus 2. X can be anything. There are infinite values. It can be 0.2, it can be 9.1, it can be anything. But the moment I say x is a positive integer, find x plus 2. Even though now also it's infinite, but the possibilities have greatly reduced. Now it's an integer plus 2, right? Then I could go on and say x is a positive integer, find x plus 2. Again, my possibilities have further reduced. This is what constraints are going to do. Instead of allowing you to take any value in the world for your variable, it's going to put limits on it. And you have to be careful about this. I talked about this at the beginning, that suppose a question says x is a positive integer, and after all of your solving, you come to two values, negative 2 and 1. You have to reject that negative 2. If you just do all of your work and then you forget about that one thing that was written in the question, you get it wrong. So make it a point to write down the constraint in your scratch pad wherever you're solving. Write it down. I know you might feel, why do I write it down? I can read the question. But this is so easy to miss out. It's just safer to spend those 3 4 seconds and write it down. I know I've given you the tip, but let's see who all follow it actually. So we are going to see a question on this, question number 7. It's going to look scary, but again, trust yourself. Take one step towards it and let's see how this goes. So here we go. All the best. Okay, 25% accuracy. One fourth of the class got this correct. And Vernax, I'm so proud of you. Ravi asked you if this is the answer. You just said no. You did not say what the correct answer was because you know the policy. No comments, no answers in the chat. Good, thank you. Now let's discuss this question. I know it looks scary. I already warned you about this. But that's why we had given this example to first help you understand what is it that we're even talking about. So if 942 minus 249 is something you look at, I'm not going to calculate because we're already given it's a positive multiple of 7. Then A, B, C are non-zero digits. Non-zero digits 1, 2, 3 till 9. How many three-digit numbers A, B, C are possible such that this difference is again a positive multiple of 7? So if you observe this A, B, C, here A is 9, B is 4, C is 2. And then C, B, A just means that B still stays in the middle. It's the A and the C that change places. This is exactly the kind of numbers we're trying to look at. One such number is here. Your ABC is 942. We are asked how many such ABCs are there. Now it completely looks as if what is this these are just letters of the alphabet. You are subtracting ABCD from CDBA. What are you doing? Well, change it to math. If I say you have the number 53, it just looks like two digits placed together, right? 5 and 3. But then when you write it in the expanded form, that's 50 plus 3. That's how 53 is created. You can do the same expanded form notation for these and you'll see a lot. So ABC is actually the same as 100A plus 10B plus C because A is in the hundreds place and so on. Similarly, CBA can be written this way in the expanded form. Now I'm subtracting them. So I subtract them and I get 99A minus 99C. Much more easy to understand compared with this thing. Here I had letters subtracted from letters. Now I at least have 99 times a number minus 99 times another number. And in fact, I can even take 99 common. So this thing is what you want to be a multiple of 7. Is 99 a multiple of 7? No. Then how will this whole thing be a multiple of 7? If A minus C is a multiple of 7. It's like one of these had to be. Both of them could also have been divisible by 7, but 99 is not. So A minus C has to be. Now, A and C, what do I know about them? Single digits, non-zero digits. So I want to see what can these be so that the difference is divisible by 7. Well, this is a very important inference we made from the previous step. Now, if a number is divisible by 7, it can be anything: 0, 7, 14, 21. It can go on forever. But can it go on forever for our question? Because we already have some limitation on our variables on A and B. They can't just be anything, they just have to be something between 1 and 9. So if A and C are single digits, how can A minus C be a double digit number? This also has to be single digit, and that will help you reject 14, 21, everything. So you will only be left with 0 and 7, first of all, but then you'll also reject 0. Why? Because ABC minus CBA, we are given this is a positive multiple of 7. If A minus C is 0, then this entire product here, that will be 0, right? And you're not allowed to do that. So here, every part, everything in the question mattered so much. This little thing, one word, positive multiple of 7, so easy to ignore. But if you do ignore it, you would not remove this 0 from here. That would still stay in your calculations. Now, A minus C therefore is just 7. There are only two pairs, as Kshitij wrote here, 9 comma 2 and 8 comma 1. Again, if you had not removed this 0, this A minus C equal to 0, you would have thought about all possibilities where A and C are equal, right? That could have been 1 1 2 2 3 3. You would have so many. But then that's because you missed out a constraint given to you in the question. First, about what ABC even can be. That helped us reject these double digits. Second, that it cannot be 0 either. So correct answer that you get here now, remember, it's about ABC. So you not just have to select A and C, you also have to select B. Look, AC, I'm good with this. But is then 2 the answer? 2 is not even in the choices. Think. For every pair AC, B can be anything, right? There is nothing here that you see about B. So, how many possible values are there for B? 9 possible values because B can be any non zero digit. So, for each pair, 9 B's. So, 9 B's for this one, 9 B's for this one, total 18. You can also multiply 9 times 2 possibilities. So, 18 possible numbers are there. E is the correct answer. So this had super low accuracy. Tell me if you guys understood this. A mole isn't B distinct from A and C. Where is that written, a mole? Find that for me. A constraint which is stated, we miss that. A constraint which is not stated, we assume that. Just look at this. Don't miss what is written, but don't assume what is not written. A mole says got 14. Okay, how? Because you assumed the distinct part. Yeah. You removed what all? But then if you thought these were distinct a mole, you would remove 1, 2, 8, 9. You would remove 4 possibilities. So you would have 5 B's. Even then your answer should have been 10. You still did something wrong then, a mole. Representation states ABC. Isn't it implicit? Oh, that's a good question. That's something so many people do. So, this is what they think. So, there are two unknowns, A and B. Just because I've given a different letter to each of them, a different variable, A and B, it doesn't mean they're different. A can be equal to B unless stated. Now, I'm so happy you asked this because this is something that doesn't easily get clarified unless you make a lot of mistakes. It stays in your head. I mean, why are you calling them A and B then? Why are you not just calling them A and A if they're equal? Well, if I call them A and A, I'm saying they are always equal. But when I'm calling them A and B, they can be equal. That's very important. Amol, I hope you understand that. And everybody else who had this issue, I hope we have resolved that here. Okay, so is everyone clear with this? Any questions? If not, then please write C for clear in the chat. Meanwhile, let's have the poll for question 8, please. Guys, tell me you've understood this. This was loaded. This had so much. Okay, Pratyaksh is clear with this. The people who, okay, SP is clear. Good. Now go with all of that new confidence into number 8. All right, good. Akshay is also clear. Here's number 8, everyone. All the best. All right, so 32% is the accuracy for this. Choice A is the correct answer. Let's see. Again, this looks hard. I trust. I know what you felt when you looked at this. This has fourth power. I mean, even solving a quadratic equation takes a little bit more effort than if it was linear. That's just so pretty. This is fourth power. It can get scary. But then look closely. You would notice that this term here is exactly the same as this denominator here. So if you cross multiply, you are going to get this whole square equal to 1. Now tell me, the square of which number is equal to 1? It's only two possibilities. There are two cases here, which are what? Either this thing is equal to 1, the thing inside, or this is equal to negative 1, because it's only 1 or negative 1 whose squares are equal to 1. There's nothing else. So something that just looked completely, undoable, that I can't do this, I don't know what to do, after one little simplification, you started to see things. It just became a whole square which was equal to 1, which then gave you a lot of information about the number inside. Now, when I'm trying to solve this, of course, the 1 and the 1 get cancelled out. I get x to the power 4 plus x squared is equal to 0. Now, when you factor that, this is what you have. So it's a product of two numbers which is equal to 0. And how can the product of two numbers be 0? Either the first number is 0 or the second number is 0 or both, if both of them are possible together. So x squared equal to 0 will give you x equal to 0. But x squared plus 1 equal to 0 will give you x squared equal to minus 1. Now, I see somebody talking about, Christian talking about complex numbers here. X is equal to iota. But GMAT does not deal with imaginary numbers at all. It's only going to be real numbers. So there is no real number for which the square is going to be negative 1. This gets rejected. Now, this is a constraint. Yes. But was it stated in the question? No. Every constraint will not be stated in the question. If it is a conceptual constraint, something that comes by definition, it's not going to be stated. Otherwise, of course, they have to tell you that this is what you can take, this is what you cannot. But conceptual constraints you have to consider on your own. So from all of this, from the first case that we did here, we only got one value. Similarly, look at this. X squared, positive number, or 0. X squared plus 1, definitely positive. How can their product ever be a negative number? It's not possible. Again, because of conceptual constraints. So the same conceptual constraint on the square of a number helped you reject 2 out of 3 cases. 3 cases otherwise would have looked like, no, 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 there are too many possibilities, this statement is insufficient. But because of this one conceptual constraint, 2 cases are out. You're only left with one possibility that gave you a sure answer, making statement 1 sufficient and helping us reject B, C, and E. That's how important this is. Okay, Christian didn't know that. Mazar says maybe a simple approach, only one is the number which is equal to its reciprocal. That's a very good observation. What you see is it's the same number here and here. So, which number is equal to its own reciprocal? Observation is good. Answer is not correct. I didn't say that. 1 and minus 1. Both of them have this. When you take the reciprocal of negative 1, even then it's equal to negative 1. But observation wise, good job. Now let's look at statement 2. This is simpler. This is where I can factor this out. I can take x square common, and I really have the same thing that I had here in case 1, but almost the same. But here you have x plus 1. Again, two numbers whose product is 0. Any of them can be 0. You get x equal to 0 or x equal to negative 1. So here you get two possibilities. And both these cases, when you consider, you see that it's not sufficient. So the thing that looked so hard, that this can never be sufficient. This might have 4 solutions because it's x to the power 4. And this one, which looked easier, this is insufficient. So don't assume something from how it looks. You need to put in the right effort into simplifying it. Use your constraints, consider all cases, keep all of these skills in your mind. Don't make any assumptions, and you're going to be golden. Can we take the square of this thing and reduce to absolute value? So you're saying that the absolute value of x to the power 4 plus x squared plus 1 is equal to absolute value of 1. Even then, you're going to get the same two cases. If I didn't get your question, then please put it again and Ashish will help you. So here, A is the correct answer. I hope everybody understood this. Uh, but here we have 1 on the right hand side, so we can consider no, Mazir. What if it's negative 1 equal to 1 over negative 1? They are equal. They still are equal. Be careful. Okay, so time for the last question of the day. Let's put in all of our energy into this. This is a hard question. Let's put our complete energy, everything that you've learned into this final question. And then I'm going to give you some great tips for how to break the barrier. We've been doing that throughout the session, but don't miss the summary. So let's have the poll for question number 9, please. And this is it. Good luck. All right, you guys took pretty long on this one, and even now the number of attempts is quite low. So we could tell that the reasons here could not just be skills, it's also conceptual gaps. You probably did not know how to infer what this thing here means, number of positive integers of x that are divisors of x, but less than x. So all of this part, because of conceptual issues, it probably took you very long, and still we don't have a very good accuracy. So let me help you with the concepts, and then you can think along with me as I explain the solution of whether you would have been able to do this or not. If x is a positive integer, how many positive integers less than x are divisors of x? So what are divisors of x? Let me think about a number. Let's take 6. So what are the divisors of 6? It's 1, 2, 3 and 6, four divisors, right? But those are all of the divisors. Instead, if I say which of these divisors are less than 6, because you want those divisors to be less than x, so less than 6 is everything other than 6, right? It's 1, 2 and 3. That means the one divisor which is not less than itself is the number itself. So there's one divisor that you don't count. Every other divisor is always going to be less than the number. I hope you understood that. So here, really, what I want is total number of factors minus 1. What is this one factor? It's the number itself, because this number is a factor of itself, but it's not less than itself. This is what I want to find out. Now, this is closer to a formula that some of you might know, which is how do we find the total number of factors of any number? Well, you just prime factor your entire number. Then there are powers on those prime factors. You increase them by 1 and multiply those increased numbers. If you know the concept, you know, otherwise, you might feel overwhelmed by this. But look at its application in statement 1. So statement 1 says x squared is divisible by exactly 4 positive integers less than x squared. Again, what does that mean? Total factors minus 1. It's just the same thing you had in the stem. So this is equal to 4. Now, if this is equal to 4, then total number of factors of x squared, it's 5 of them. Now, from the formula that I talked about, Aditya Narayan also helped us with it. If the powers are a and b, then a plus 1 times b plus 1, that gives you the total number of factors. So it's some product that is giving you 5. Now you think about what kind of a product can give you 5. The only product that can do that is 5 times 1. Now, 5 times 1 means those increased numbers are 5 and 1. That means what were they before the increase? 4 and 0. But 0 means that prime number did not even exist. So really, there was only one prime factor. So observe this very carefully. It's a plus 1 times b plus 1. It's this product which is 5. And we found out the only way this is happening is 5 times 1, which means 5 is equal to a plus 1, or a is 5. 1 is equal to b plus 1. But that would mean b is 0. That would mean this prime factor here, p2, does not even exist. So you don't count when the power is 0. That means you only have one prime factor with a power of 4. Very, very important inference here. So this shows you the form in which x squared exists. It's the fourth power of a prime number. From this, it's easy to get x. So x is what? P1 squared. So x is the square of a prime number. Now, how many total factors does it have? Again, use the same formula. No, you have it in the prime factored form. Increase the power by 1. It's going to become 3. There's nothing else to multiply. So 3 is your total number of factors. I got this by again 2 plus 1. So if 3 is the total factors, what I wanted was total factors minus 1. Of course, I can do minus 1. Your goal should just be to be able to find total number of factors of x. And we could do that here, which makes this statement sufficient. B, C, E are out. Pretty involved. This question really required thorough conceptual understanding. Once you have that, though, then it's not going to be hard. You translated what the question asked in terms of this for which you have a formula. Then you just applied that formula and just look at the calculations. It's just 5, writing that as 5 times 1, then just increasing one number or decreasing it by one number, plus 1, minus 1. It's not complicated calculations. It's not complicated inferences. If you have a strong conceptual foundation, this is going to be true for every question you do. Nothing is going to just stump you. Statement 2 now. 2x is divisible by 3 positive integers less than itself. Again, it's total number of factors minus 1. That's 3. So how many total factors does it have? 4. Now, how does 4 come? 4 has to be expressed as a product. So 4 can be expressed as a product in just two ways: 4 times 1 or 2 times 2. If it is 4 times 1, then again think a plus 1 is 4, b plus 1 is 1. You will get what form? This, p1 to the power 3. But if it is 2 times 2, then a plus 1 is also 2, b plus 1 is also 2. So a and b are 1 each, from which you will get, just read the right side first, you will get p1 times p2 with powers 1. In each of them now, we have to still try to get to x, right? So if 2x is equal to p1 cubed, another very important inference, the left side is 2x. 2 is a prime factor of the left side. Then it also has to be a prime factor of the right side because they're equal. And the right side just has one prime factor, just p1. So p1 has to be equal to 2. From here, you get the exact value of x and you can get the factors. When you look at this second case, 2x is equal to this times this. At least one of these two numbers has to be 2 because 2 is a prime factor as you see on the left side. The other one is something I don't know, but I can say x is equal to p2. Could be 3, 5, whatever. But to find the number of prime factors, number of total factors, I don't care about what the prime factor was. I care about the powers only. I just have to increase that by 1. So here also, I will be able to get the total number of factors. So this statement is not sufficient ultimately because the two answers don't match. Although I could get answers from each of these cases, the answers did not match. That's why statement 2 is insufficient, making A the final answer. I know you people must have found this hard. You were taking a lot of time with this. The people who did solve it got 40% accuracy. But believe me, concepts once settled. This question was heavy because of concepts mainly. Other than that, as you go from one step to the next, it's always going to be a smooth transition. This is a hard question, there's no doubt about it. But what makes a question hard? Either us not knowing the concept or not knowing how to apply that concept. Here, it was mainly, I believe, the concept part. In other questions, you people knew the concepts, but it was application where you struggled. Now, I chose this loaded question to just show you that if it's a hard question, then there are a lot more skills that are needed. So you see translate thrice, you see infer thrice, you see all cases. So many skills work together to help you go from the question to the answer. Not the question does not get hard. Concepts don't get hard. It's like you know them or you don't know them. Once you know them, it's only skills. It's only skills. When you use process skills the right way, you just see when you're on harder questions, this use becomes more sophisticated. It's not as easy as it was on a simpler question, but concepts don't get hard. It's the same concepts that you've already learned. Most of you would already know concepts. The same concepts will come. You learned them at school, in fact. But still, GMAT is hard. It's hard to score on because of these skills. It's the style of questions. All of these process skills, 7 of them. I discussed 5 of them in class here in this session today. 2 of the remaining ones I would encourage you to explore about. So there's this link about the process skills. Go through this, you will find out about the remaining 2 skills, of course, but also look at more examples about the first 5 process skills. This is very, very important. Now, These are three key mistakes that I encourage you never to make. Just be very cautious about them. One mistake is that students do not focus on learning the process to solve questions. Their focus is on learning what the concepts are. This is the concept, this is the concept, now I'll solve it. But it doesn't work that way. You go blank when you see questions. You need to learn how to apply. Second, you don't do proper strategic review of solutions. So just doing a question and moving to the next one, and then the next one, and then the next one, nothing is going to change. Nothing is going to improve. Sit with a question, find out where you faltered, find out how to fix it, and then fix it. Then this number of questions things, I'd already talked about this. It's not the quantity, but the quality. So, my concluding remarks to you would be that your ability to solve hard questions, the last one was really hard, this ability will increase on its own as you get more skilled in applying process skills, as you get comfortable with, okay, this is translation, I'm just translating from here to here. Oh, I have to consider all cases, or oh, there's a constraint given. As you get comfortable with that, as you build ability with that, questions are going to seem easier to you. Then, strategic review, do not leave that. Improve your ability, learn from your mistakes, don't repeat them. Of course, you need to have detailed solutions that help you do that. At EGMAT, every solution is super detailed to help you find out exactly where you faltered, and you're going to have exact files, targeted files to fix the gaps that you show. So Quant 2.0 is a solution for all kinds of students. Whether you're a pro or a novice in Quant, it is going to happen. These success stories, these numbers talk for themselves. This biggest share of Quant successes, it all happened because of the methodology on which the course is based, the core skill focused approach, not the practice based approach. Now, this main theme for the session today was, wherever I am at, how do I get to that Q50? I told you one way to break that barrier. You need to build strong conceptual foundations. You need to get comfortable with process skills. You need to have your own plan as well. Everybody here might have the same destination in mind, but the starting point is different. So you can customize that study journey and learn from the most successful experts at EGMAT. How can you customize that? Let me tell you. So this is a typical module in the EGMAT course. It's even and odd numbers. Every single module has diagnostic quizzes first to diagnose your starting ability. Then you have concepts where you learn a concept. Then you have a concept practice quiz where we test that concept, just the concept. Then you have a process skill learning activity. So you learn how to apply. Then you practice how to apply. Then you learn how to solve GMAT skill questions. Then you practice GMAT questions. Every module has this. It's bound to prepare you for that module completely. It's like this one module you do properly, and if this was all the exam had, you would ace it. So if every module you ace on, just see what will happen on the whole of Quant. Now, this is proof of how success happens. So, Srishti, in 3 months, went from 630 to 730. Just look at her quant improvement from a Q42 to a Q49. That's a lot of improvement. Go on and check percentiles. I encourage you to look at that. That's a huge difference going from here to here. Srishti said she needed to learn right from the basics. She didn't have very strong conceptual foundations. She started here, and that's exactly what she got. She started at the base level and then went just till where she wanted to be. Now, you can click on this link where we've shared Srishti's story also and watch her encouraging video. It will motivate you truly. Here's another story, Halima's story. Now, here it's a 150-point score improvement. You people must feel, if I'm at a 600, how can I ever get to a 750? I don't think that can happen. Somebody at the top of the session also asked if that's even realistic. Should he even be asking that? but you can. It happens. So you watch this journey. The key highlights you're going to find is what was she doing wrong when she prepared the first time, how she could fix her mistakes when she joined EGMAT, how did Scholaranium help her find mistakes. It's one thing to know how to fix, but you will fix when you know what is wrong, right? So how to find all of those mistakes? You can't read so much data on your own. The system captures every click that you make on the platform. And then what is it that led to this great improvement in just 3 months? What is the approach and the importance of a popular study plan? Sorry, a proper study plan. You need to have a plan that's for you. So customized learning, if you are at a Q45, then look at something like this. You say you take the GMAT skill diagnostic, you're not too good with it, it's 63%. Then you take the concept diagnostic, you get 100%. What does this mean? You're not ready for GMAT, but you're great with your concepts. So because of that, everything which had the concepts part is de-highlighted for you. You don't have to do that. So it's specific to your abilities. You don't have to do everything. It's what you need. This is what our pace engine does. It helps you skip things that you don't need. So if you look at this here, course duration in total is 27 hours and estimated pace time savings is 9 hours. The one third of the course is gone because you don't need it. So spend time where you need to. Don't, otherwise you'll just feel all over the place. What all do I do? There's so much to learn. Don't let yourself get overwhelmed. Let the system do all of that analysis for you. And then learn how Ronak saved 40 plus hours of prep time. So for Ronak, this is specifically here because he saved a lot of time using this customization that I just talked about. And if you are at a Q47 or a 48, you're already at a high score, pretty high up there. It's even harder to find those gaps because see, if I know I have this concept gap, I can go and fix it. But if I know all the concepts, then I have to be all the more careful when I'm doing my strategic reviews in trying to find what mistakes I'm doing, what skills am I lagging. So Scholaranium will help you do that. When you look at this dashboard, everywhere that you see these red marks, these are your weaknesses. If something is completely green, you're good there. So section wise, topic wise, you're going to get data here. You'll know exactly what your weaknesses are. Watch this success story where you'll see the impact of Scholaranium in helping you understand what you even need to work on. Overall, what does it take to get to that high score, to get to that dream score? It takes all of this. Good concepts, solid concepts, perfectly solid concepts, process skills, which are about how to apply, GMAT skills, the final level where you start to solve GMAT style questions. You have to ace all three levels and with your own unique solutions, with your own personalized courses that are powered by our expert AI through diagnostic quizzes, as I said. So we judge your performance when you start through a diagnostic, and that's how we customize the full course for you. You're going to get feedback every 10 minutes into the session and look at how other people have done this before you. Here's inspiration again for you, leaving this on a very positive note here. I thank you all for joining me in this session. I hope this added value. Let me know what you guys thought about all of this. I am reading your comments and let me know what would you like to see next time before we call it off. Make sure you guys spend time on process skills. The link is there. All 7 process skills. This is going to change the way you prepare completely. Okay, these are all of the skills, and you will break the barrier for sure. Thank you, Akshay. Thank you. It's pretty late in India for all those people who are still studying. So it shows what you have, the desire to succeed. And we're there with you in this journey. I'll see you again in another session. Till then, all the best. Good night. Good day. Bye bye.